All right, so today we're going to be mapping multiple variables in ArcMap. So we've been talking a lot about bivariate mapping in our discussion of symbolization, and you will be exploring that further through Lab 4 in the Carto platform. But this video is meant to be a resource for you in later projects when you want to review how to map two or more variables in ArcMap. Okay. We are not expecting you in this course to be able to do that from a technical basis, but we do want you to be familiar conceptually with why you would want to map two variables at once and strategies for doing so. So this technical walkthrough should provide you some help for that and a resource for later projects and other courses. Okay, so our data here, we have census units for a census of farmers throughout Canada. We are zoomed into Ontario and Quebec here. So we are going to be mapping different attributes of farms and farmers. Okay, so we'll enter our layer properties, okay, in the symbology tab. The basic is we're mapping all the census units the same color, all these features the same color. But if we had categorical data or nominal data representing different kinds of farmers, for instance, or different kinds of census units, we could use the category tab here to display that. We can go ahead and, for instance, just map the names of the different census units. Okay, assign each census unit a different color. Okay, and since we have a lot throughout Canada, it's going to take a while to load up, but each one is more or less going to get a different color. And we get this kaleidoscopic pattern. Not particularly useful for us, but you can see that we did have some really important categorical data on the kind of census unit, the kind of enumeration unit, or some attribute, nominal attribute of that census unit. We would be using this tab here. Okay, really what we want to focus on is on quantities. Okay, this is bread and butter of thematic mapping. In this first option here, graduated colors, all that means is choropleth. Okay, so we are going to map the percent of farms, or the ratio, excuse me, we're going to map the ratio of farmers per acre. It's kind of a meaningless number, but it's the data we have, and maybe we'll be able to see some interesting patterns. Okay, so we know that with choropleth mapping like this, we need to have process-derived data, so we're going to be mapping number of farmers per acres that are farmed in a census unit. Okay, so I happen to know these are not particularly illustrative field names. I happen to know what they mean. So this is our number of farmers in a census district, and this is the number of acres in a census district. So this is normalizing it and turning the number of farmers into a ratio, farmers per acre in each census unit. Okay, so it's kind of density of farmers. Okay, and we're going to use the standard classification, and we will map that. Okay, so if we were to zoom out, we would see that actually most of the interesting patterns are over here in BC. Okay, where you have a lot of farmers operating in very small farms. So there's a real density of farmers out there. A lot of farmers operating on a fewer number of acres. Okay, small vegetable plots, orchards, that sort of thing. So that shows us more or less what we expect to find out. Okay. But then we can actually start getting into some of the symbolization that we have been exploring more recently in class. Okay. So graduated symbols. Okay. So this is where we can actually use our total data. Okay. So simply just number of farmers per census district. Remember, with using proportional point symbols, we can use that total data. So let's map out the number of farmers per census unit. Okay, and some interesting patterns emerge. Okay, we can see more farmers per census unit here versus elsewhere. Okay, so we've used our area data, and we are representing it using point symbols because we have total data. Okay. These are graduated symbols, so we create 5 different classes of circles representing different ranges in our data. So the smallest circle represents census districts with 0 to 95 farmers, so on and so forth. We also have the option to do repetitive dot mapping or dot density. Okay, so we could map the same things, the number of farmers. Okay, so each dot is going to represent a certain number of farmers. It's going to be randomly placed within each census district. Okay, this gives us a different view of the data. Okay, so this is an option available to you for certain kinds of phenomena and data, but it is an option for you to implement in ArcMap. Okay, and we can adjust the value of our dot, how many farmers in this case it's going to represent, and the size of the dot to change the appearance. Okay, this is less informative, so we might actually want to decrease the size and value. See different patterns emerge. It's something they have to play around with. Okay, we have charts. Okay, so we talked a little bit about representing, symbolizing data based on charts. A few different options. We have bar charts, stacked bar charts as well as pie charts. One thing we can explore to see this is we have data on the number of farms, not farmers, but farms in each census unit for 2011, which is this number, and 2016, which is that field. And so it's going to take a while to load. And it's going to give us these lines because it's trying to prevent chart overlap. Okay, we don't necessarily need to worry about that in this case, for right now at least. Okay, and essentially what we're seeing here is we are looking at the ratio of farms in 2011 to 2016. So this dark blue is going to be farms in 2011. The pinkish color is going to be farms in 2016. So when there's more blue in that pie chart, there were more farms in 2011 than in 2016. Okay, when there's more pink in that pie chart, there were more farms in 2016 than 2011. So if we were to adjust the representation here so that we could see all the pie charts, we might get a sense of the trend in terms of whether we've lost farms in Ontario over the past 5 years. And one thing, you might be a little disoriented about how these are oriented and the fact that they're kind of on their side. One thing we can adjust is kind of turning them through this properties window and adjusting the orientation so that they're more up and down and perhaps easier to read. Okay. Finally, we have multiple attributes. So this is where we're really going to start exploring how to combine area-based symbolization with point-based symbolization. Okay, now I will say that ArcMap is not very good technically, at a technical level, in implementing this. So we will go ahead and see what it takes to do that, at least for one layer. Okay. So we are going to start here by mapping our, choosing what attribute we want to map as the choropleth, or the kind of background base map, what we are choosing to shade our areas with. Okay, since we know choropleths need derived data, we're going to choose one of our attributes that is derived data, in this case the average age of our farmers, which I happen to know because I'm familiar with this data, is that attribute. Okay, so we are going to add all those values. So this is every census unit here has more or less a different average farmer age. We are going to remove these zeros, which we don't have any 0-year-old farmers, so we're going to remove them. Those are some sort of error. Okay, so this is going to be our this is going to be our base map. There's a few more things we need to change first. We need to change our color scheme because we want it to indicate increases in age, and increases in average age. Okay, rather than categorical differences in age. We want that the value of this color to get darker as the value of the average ages increases. Okay. Okay, and if we try to apply that, it's going to tell us we need to choose our second attribute. Okay, so we are going to then choose the point symbol that we want to represent our data with. Okay, and so we are going to choose size of our, going to choose to vary the size of our point. Okay, and we want that data to be, let's just say, number of farmers. Okay, so the larger the point or circle, the more farmers. Okay, and it'll actually give us a graduated point symbol here. So then we can apply that. And we got to change the color of these point symbols so that they're not blue and fading in with the blue on the map itself. So let's go ahead and do that. So what's going on here? So on the base map, or as our choropleth, as our areas shaded by color, we have the average age of farmers in that census unit. So the darker the census unit on the map here, the older the average age of farmers is. Okay, so we can kind of see some trends. Younger farmers in this part of southern Ontario, around KW and Guelph. Older farmers on average in northern parts of Ontario and Quebec. Okay. And then we also have these circles that just tell us, okay, well, how many farmers are actually in that census unit? Okay, so we're mapping two different variables and combining symbolization approaches in order to do that. Okay, one a choropleth and one proportional point symbol. Now we've done that in the same layer because we have that data all together in the same layer, this farmer's layer. Another approach here is that if we have two different layers, one polygon-based and area-based layer, we could symbolize that. And then if we had another point layer, we could add that on top in our table of contents and symbolize that. So if we have two different pieces of data, two different shape files, that is also another fairly straightforward way of symbolizing multiple variables.